Servicing the 1977 GMC Motorhome. The 1977 GMC Motorhome contains many product changes and improvements. Many of the changes are significant to servicing the vehicle, and those changes are what we're going to talk about. Principally, we'll be talking about the new 403 cubic inch engine, the new instrument panel, and air conditioning heater system, plus some minor chassis and living area changes. Starting early in the 1977 calendar year, the 403 cubic inch engine replaced the 455 engine as standard. The 403 engine has a bore of 4.351 and a stroke of 3.385 inches, develops 148 horsepower and 325 pound-feet of torque. The physical size of the engine is the same, but it is a slightly smaller package, and the venturi rings and brackets are no longer used around the fan, so you'll have a little more working room. Physically, it closely resembles the 455 engine, and service is almost identical. Tune-up specifications vary somewhat, though, and are found on the label on the rocker cover for reference. All 403 engines are equipped with the TRC throttle return control, or throttle kicker, that was used only on California engines in the past. This system reduces hydrocarbon emissions by controlling the rate at which the throttle closes. You'll find complete servicing and adjustment procedures for this system in the 1976 Maintenance Manual. California engines only have a dual advance retard vacuum diaphragm on the distributor, plus an additional low-temperature thermal vacuum switch and a check valve in the manifold vacuum line to the new thermal vacuum switch. The high-temperature thermal vacuum switch is a carryover for all 50 states and is still used for overheat protection. On the California system with 2 vacuum switches, when the engine is cold, both vacuum switches are open through the top ports. Manifold vacuum is applied through the check valve to the advance side of the distributor diaphragm. Manifold vacuum is also available to the retard side of the diaphragm, but the vacuum for the advance force overrides the vacuum available for the retard. In the normal operating range of 160 to 220 degrees, with the throttle open, the low-temperature thermal vacuum switch is shifted so that ported vacuum goes to the advance side of the distributor and thus controls the vacuum advance in most driving. However, when the throttle closes, ported vacuum drops off and manifold vacuum on the retard side of the diaphragm takes over. The spark is retarded in this condition to reduce emissions of carbon monoxide and unburned hydrocarbons. And if the engine temperature gets above 220 degrees, the high-temperature TVS shifts and directs manifold vacuum to advance the spark until the engine cools. This operation is effective on all engines. On the engine, the low-temperature switch is the one on the left side as viewed from the driver's seat. It is very simple to test. With the engine cold, the top and center ports should be open to each other, and the bottom port blocked. At normal operating temperature, the bottom and center ports should be open to each other and the top port blocked. Replace the TVS if it doesn't check OK. With the 403 engine, there are some changes to the maintenance schedule. The carburetor attaching bolt torque should be checked at the 3,000-mile maintenance only. If any bolt has less than 48 inch-pounds, then you torque them all to 120 inch-pounds. And always follow this sequence: 1, left rear, 2, right front, 3, right rear, and 4, left front. Engine idle, as specified on the rocker cover label, should be set first at 3,000 miles, then at the first 12,000-mile maintenance, and at each following 12,000-mile interval. In the PCV system, replace the air cleaner filter each time the valve is replaced. The replacement interval is still 24,000 miles, but in severe operating conditions, the interval should be reduced to 12,000 miles or less. Spark plug wires should be inspected and cleaned using a cloth or soft bristle brush with mild detergent solution every 12,000 miles. Replace the wires if they are damaged or corrosion cannot be removed. Spark plugs now are scheduled for replacement at 12,000 miles instead of 6,000. If there is misfiring between plug changes, try cleaning and re-gapping the plugs, provided they are in good condition. One other maintenance item to note is the automatic transmission fluid change. The specified interval is still 12,000 miles, but should be reduced to 6,000 miles or less in severe operating conditions. Now let's look at the other major change, which is all new for 1977, the instrument panel and the chassis heating air conditioning system. First, the panel is restyled with a new ashtray, new glove box, and new radio for 1977. The air conditioning outlets are the automotive louver type, and the heater outlet is molded into the lower right center of the instrument panel. The left-hand air conditioning outlet has a shut-off door with a thumb wheel control knob, so that the airflow can be increased on the passenger side or out the center outlet. AC outlets are removable from the front of the panel. All you have to do is catch a screwdriver or tool J24612 under the head of the spring-loaded plunger, and they'll pop right out. The electro-level control has been moved from the instrument panel to the driver's left side. This change will affect the procedure for removing the brake pedal, since we formerly used the control opening for access to the pedal. A new service procedure will be released and will be included in the new service manual. The heating and air conditioning system uses an automotive-type control head, which has new face markings but functions basically the same as before. The lower temperature control lever cable operates a blend air door. It also operates a vacuum switch to control opening and closing of the heater hose water valve. The upper functional lever operates a vacuum selector valve to control all the doors in the system except the blend air door, plus an electrical switch to turn the compressor clutch on or off, and a high blower override switch for maximum air conditioning. There are two air conditioning selector positions. The maximum position is automatic high blower and uses recirculating air. The normal position allows selection of the blower speed and operates the AC on outside fresh air. The economy positions, vent and heater, are those in which the compressor doesn't run. Vent air is discharged from the heater outlet and the AC panel outlets, and can be warmed depending on the temperature control position. In defrost, the compressor will run for dehumidification if the outside air temperature is high enough. In freezing weather, the pressure will be too low to close the low-pressure switch. Moving around to the engine compartment, the new air conditioning and heater unit is mounted above the condenser and radiator as on past models. It has one or two baffles, depending on the engine, at the sides to help lower the inlet air temperature at a standing idle. The baffle on the passenger side is installed on all 1977 models. The baffle on the driver's side is installed with the 403 engine. The aluminum baffle at the front and top of the unit prevents the blower airstream from sucking in rainwater off the windshield. There are two changes to make the condenser and radiator more efficient. First, the heavy-duty fan drive is standard equipment on all models. Second, with the 403 engine, there are baffles installed beside and below the condenser, which help cool it at idle. All of the new baffles help to reduce the amount of engine compartment air that is recirculated through the condenser and are essential to good air conditioning performance when the vehicle is in an idle condition. Now let's look at how the four main components of the air distribution system tie together. Air enters through the heater and AC assembly in the engine compartment, where it is heated or cooled, or a combination of both depending on the control setting. From the top of the heater AC assembly, air can be directed through a defrost door to the defroster nozzles at the top forward edge of the instrument panel. An opening in the rear of the assembly allows air to flow to a distribution box under the instrument panel, and the distribution box directs airflow to the heater outlet and/or to the AC plenum. The AC plenum runs nearly the width of the instrument panel and contains 3 air conditioning outlets. The far left AC outlet in the instrument panel is connected to the plenum through a duct and hose. The distribution box under the instrument panel has 2 vacuum-operated doors. The upper or air conditioning door is controlled by a single-port vacuum actuator. In the AC and vent positions, no vacuum is applied to the actuator, and the door remains open to admit airflow to the air conditioning plenum. In heat and defrost, or with the system off, this door is closed by vacuum. The lower door is the heat door, and it has 3 positions, with a 2-port, 2-direction push-pull actuator. In the normal condition, with no vacuum to the actuator, the heat door is cracked about 1/4 of an inch open. This lets some air go to the floor during defrost operation. For full heat operation, vacuum is applied to the upper port, and the door opens to direct air to the heater outlets. In the vent position, no vacuum is applied to either port of the heater actuator. This means that the heater door is in its normal position, 1/4 inch open, allowing about 10% of the air volume to come from the outside and enter the vehicle through the heater outlet. The remaining 90% of air volume enters the vehicle through the air conditioning outlets. In AC, the lower port of the heater actuator has vacuum applied, and the heat door closes so no air goes to the floor. The air conditioning door, with no vacuum applied, is open at the same time. Should the air fail to discharge from the proper outlets in the AC or heat mode, you can get at these actuators for troubleshooting through the opening to the left of the glove box after the glove box cable has been removed. Check that the actuators are properly connected to the door crank arms. Check for vacuum to the actuators in the heat and AC selector positions, and check the actuators for proper operation with an external vacuum source. It will be difficult for you to actually see the doors themselves, but you can hear them open and close as vacuum is applied and released. One other important point. The heater actuator has a restrictor in the upper port line. With this restrictor, it will take 15 to 20 seconds for maximum door opening after the control is shifted. Be sure to allow it time to open or close when you're checking it out. The heater air conditioning assembly box has 3 doors and 2 vacuum actuators. The temperature blend door in the center is cable controlled through a crank arm on the driver's side. Notice the air baffle screwed to the back of the front access cover. This baffle has been added to make the temperature change smoother as the blend door is actuated. At the front left is the recirculating air door, controlled by a single-port vacuum actuator. This door is normally in the outside air position. In maximum AC operation, vacuum is applied to the recirculating actuator, and the door shuts off the fresh air inlet so that the system recirculates air inside the motorhome. The defrost door at the top has a 2-port actuator to provide 3 positions. With no vacuum, the door is closed, blocking off air to the defroster. In the heat position, vacuum is applied to 1 port, the short tower on the vacuum actuator, and the door opens slightly, so a small amount of air goes to the defroster nozzles. In the defrost position, vacuum is applied to both ports of the actuator, and the door opens fully. 90% of the airflow goes to the defrost nozzles, and 10% goes through the heat outlet. Both the defrost and recirculating doors and their actuators can be checked from the outside front of the vehicle through the vehicle access doors. The access cover and heater core must be removed from the AC unit to service the defrost actuator. While the front cover is off, Let's look at a couple of changes in the evaporator unit. Notice that the thermal expansion valve now has 2 sensing lines instead of 1. This is a different design than the one used on earlier models. It is referred to as externally equalized. The added equalizer line is tapped into the evaporator outlet, and it signals evaporator outlet pressure to the thermal expansion valve. Also, the expansion valve capillary bulb that senses evaporator outlet temperature has been relocated. It is clamped to the low-pressure vapor line in a 2 o'clock position, and this position is important to allow proper system operation. There is no difference in testing the system with the new valve, just an extra connection and a different valve part number if replacement is required. One other change in the AC system is the Freon charge. For 1977, a fully discharged system takes 3 3/4 pounds of refrigerant to recharge it, and this is indicated by a sticker on the compressor. One final change on the air conditioning system is the addition of a time delay relay in the power line to the blower motor. The time delay relay is located just over the blower relay on the firewall and causes a delay of 3 to 5 seconds in blower operation whenever the blower is switched to high. The reason for the relay is that the AC door is closed with the system off, and immediate high blower airflow would hold it closed. The relay gives the vacuum actuator time to open the door before the blower comes on. That's the story on the new AC system. Now, let's briefly cover some chassis changes that are significant to service. Up front, we have a new shock absorber for 1977 that has a longer service life. The new part can be used to service earlier models. Refer to the parts catalog for the part number. Steering tie rod clamps, nuts, and sleeves all have new part numbers for 1977. The clamp, nut, and threads of the sleeve are metric, and the individual parts are not interchangeable for past models. Radial ply tires are used on 1977 motorhomes and on some 1976 models as well. At the present, only the general jumbo steel belted radial tire is recommended. Also, the correct wheel, part number 359402, is required with radial tires. It has the word radial stamped on the inner rim. Never install radial ply tires on wheels that do not have this marking, because earlier wheels are not designed to handle the rim loads imposed by radials. Approved radial tires can be installed on earlier vehicles, but never mix them with other tires. Be sure the owner buys 7 new wheels and 7 new tires if he wants to switch over to radials. For detailed information on using radial tires, please refer to Service Information Bulletin 77 IM-1. While we're in the chassis area, let's clear up a point of misunderstanding about the auxiliary fuel tank. Some customers don't understand why the fuel gauge reading barely changes when shifting from main to auxiliary. The reason is that the tanks are connected by an equalizer line so that they fill through the same spout and empty simultaneously. The auxiliary tank, however, will still have a small amount of fuel, 7 to 9 gallons, left when the main tank is empty. Finally, there are a couple of changes in the living area plumbing that you should be aware of in the event of specific customer complaints. The optional Electro-Magic toilet flush control does not have an automatic timer in 1977. It is necessary to depress the flush button for approximately 7 seconds. Explain this to any customer who mentions that the automatic timer isn't working. In the hot water system, a check valve has been installed in the cold water line leading to the water heater. This prevents the hot water, when it expands, from backing up into the cold water system. With the check valve installed, some water may be forced through the tank relief valve during the heating, and the relief valve overflow is emptied through a hose under the motorhome body. If your customers are concerned about water in this location, you can explain that it is simply expansion overflow from the water heater. That is an overview of the service story for 1977 motorhomes. Familiarize yourself with the new equipment. Service it right and keep your customers happy with their GMC motorhomes.